boys and girls. Notice that in yesterday's lesson what we did was to add and subtract radicals, and what we'd like to do today is to multiply and divide them. So let's again look at a number of examples and see how it goes. Here we have a problem in which we have 3 root 6 times 2 root 3 minus root 2. And notice we have a monomial times a binomial. And in fact, the way in which we will handle this is exactly the way in which we have handled expressions. And what do you see here? Who would like to simplify this? Doug?
Well, you have 6 rad 8.
3 times 2 is 6 times the square root of
18.
18. All right. Minus
3
times
the square root of 12.
Times the square root of 12. Now this certainly would be one approach in doing this problem. But notice now here we have the square root of 18, and there might be a perfect square in there. In fact, there is, Steve.
It would be 18.
6 times. Now
9.
here we have 18 is 9 times 2.
So
And the square root of 9 is
3.
3 times 6.
18 root 2.
18 times the square root of 2.
Minus, let's see.
12
4
is
times 3.
4 times 3.
So it would be 6 times the square root 3.
6 times the square root of 3. Does everyone agree with that? Now, in fact, this is one pattern in which you may leave your final result. But in fact, some people might like to look at this and take out a common factor of 6, in which if we were to do so, we have left what? 6 times, 3 root 2 minus a root 3. And this then would be the most simple name. Let's look at a second example. And notice here we have a binomial times another binomial. And looking at this, we handle this in exactly the same way as we do with any other binomial expression. And who would like to simplify this? Glenn?
You get 2 times the square root of 6.
2 times the square root of 6. Good. Now let's use our distributive property again. 2 root 3 times a negative 2 root 3 is what number?
Is minus a 4 root 9.
4 times the square root of 9, but of course the square root of 9 is 3. So 4 times 3 is 12. All right. And now we have here a negative root 2 times the root 2 is
2.
Is a minus 2, and a negative root 2 times a negative 2 root 3 is what?
A positive 2 root 6.
Positive 2 root 6. Everyone agree with this? And now looking at that, we have some simpler names in there. And what then is the most simple name for this, Kirby? Here we have a 2 root 6 plus a 2 root 6 is
4 root 6
a 4 root 6
minus 12.
minus, well, here we have minus 12. Minus 2 is what? A minus 14. And again, either this might be the most simple name, or indeed you may take out a common factor here of what? Of 2, and write this as what? 2 root 6 minus 7, and that then would be its most simple name. Well, let's look at a third example. In fact, here we might generalize an idea a little bit, in which we have root a plus root b times the quantity the square root of a minus the square root of b. And what does this resemble? What does it look like, Bill?
It's similar to a plus b times a minus b.
Good, in which you know that a plus b times a minus b factors or multiplies into, Bill?
A squared minus b squared.
A squared minus b squared. So simply looking at this, you say that this then is going to be equal to, and the final result, Bill, is?
A minus b.
Is a minus b. Does everyone agree with that? It's the square root of a squared, which is a, minus the square root of b squared, which is b. Very good. Now let's then use this idea in a particular problem. Let me write down a problem such as this, in which we now have in the denominator the square root of 3 plus the square root of 2, in which we would like to rationalize this denominator. So looking at this, what number, which is another name for the number 1, that you'd like to pull out of your hat in order to simplify this? Brenda?
The square root of 3 minus the square root of 2.
Good. Here we have the square root of 3 minus the square root of 2, because from example 3, we notice that when we multiply these difference of squares, we then get a number which is a rational number. Is that right? And of course then in the numerator is the square root of 3 minus the square root of 2. This then is going to be equal to, and let's put in this denominator first, which is going to be what number, Brenda?
3 minus 2.
Simply 3 minus 2, which happens to be the number 1. In the numerator then you have this monomial times this binomial, and there you see what? A 2 root 6 minus, and here's a 2 root 2 times a root 2, which is what number?
4.
4. Minus 4, And of course, 3 minus 2 is 1 in the denominator, which we do not have to write. So here's a 2 root 6 minus 4, which again you may leave your answer either in this pattern, or else you may factor out that number 2 and have 2 times the quantity, root 6 minus 2. Okay? Well, let's look at another example. And in fact, here is a situation in which we have the cube root of a plus the cube root of b times the quantity. And again, looking at all of this and coming back here and looking at problem 3 in which you see a pattern of a minus b, what then, does anyone see a pattern here in problem number 5? And what can you say about that? Can anyone go right to the final result? And Doug?
A plus B, the quantity cubed.
A plus b, the quantity cubed. Not quite. Does anyone see any pattern there? Well, let's see. Now, if you don't see the pattern, let's actually multiply it out and see what happens. Brenda, what do you think?
A cubed plus B cubed.
A cubed plus b cubed. Well, not quite either. Kirby, what do you think?
A plus B.
A plus b. Good. A plus b. Well, let's convince ourselves that this is indeed what the case is. Now, without writing that final result in here, let's actually do this product. The cube root of a times the cube root of a squared, of course, is what? That's simply a. And here now we have the cube root of a times the cube root of ab. There's a minus what? The cube root of a squared b. Does everyone agree with that? And here's the cube root of a times the cube root of b squared, which is a plus the cube root of what? ab squared. And now we have the cube root of b times this number, which is what? Plus the cube root of, let's write that as a squared b. And now we have this number times this number is what? Minus the cube root of what? a b squared. And finally now we have the cube root of b times the cube root of b squared, which is plus what? Plus b. All right, now let's look at that and see what happens. And here we have the cube root of a squared b, that's a minus the cube root of a squared b, plus the cube root of a squared b is a name for 0. And here is the cube root of ab squared minus the cube root of ab squared is a name for 0. And lo and behold, Kirby says that we have a plus b, and that's the most simple name. Very good. Now let's utilize that idea in which we now have a problem in which we have in the denominator the cube root of 2 minus 1. And again, we'd like to rationalize this denominator. So looking at this expression, we'd like to come up with a name for the number 1, and perhaps that name might be a bit messy, but we'd like to now take this number times some number here, which is then going to give us a rational number. And from example 5, as we have done here, does anybody see what that pattern is? Can you pull out of your hat what that is, Malcolm?
Now, the cube root of 2.
The cube root of 2 squared, which is, let's just write in that number 4. Is that right?
Okay.
This
Plus-
is a minus, so it has to be a plus here.
Plus the cube root of 2.
The cube root of 2 times 1, which is 2. All right.
Plus the cube root of 1.
The cube root of 1, which is 1. Okay, now that happens to be the number in the denominator, and of course we then will have the same number in the numerator. Is that right? And plus 1. And now, when we multiply that denominator, the cube root of 2 minus 1 times all of this then is going to give us what number in the denominator? Malcolm?
2 minus 1.
2 minus 1. Very good. Of course, 2 minus 1 is the number 1. In the numerator, it's 1 times all of this, which is all of that, plus the cube root of 2 plus 1. And of course, this all then simplifies simply to the cube root of 4 plus the cube root of 2 plus 1. And that then would be the most simple name for this original expression as we have right here. Okay? Well, let's look at a last example. I think that's probably all that we need to do for today. Here we have a problem in which it looks like a rather messy fraction, but again, just looking at it, is there another name for the number 1 that you would like to multiply through by in order to simplify this? And just looking at that, can you come up with some name for the number 1? It looks like the square root of x here and the square root of x here might be got rid of. And Kirby?
Root x over root x.
The square root of x divided by the square root of x. And when you do so, let's put our next line down here, we have then the square root of x times the square root of x, which is x minus, is that right? And here we have the square root of x times 1 over the square root of x, which is 1. all divided by, now here we have the square root of x divided by the square root of x, which is 1, and you're left with that numerator, namely 1 plus the square root of x, which happens to be in the denominator. Now, you're right back to a situation such as we have just done, in which you now would like to look at this, and give me another name for the number 1 here that we would like to multiply by. Peter.
1 minus the square root of x.
Good. 1 minus the square root of x divided by
Divided by 1 minus the square
1 minus the square root of x, which is a name for the number 1. And now let's see what we get there. In the denominator, it's 1 plus root x times a 1 minus root x, which is what number in the denominator, Peter?
1 minus x.
1 minus x. Now notice in the numerator we have an x minus 1 times 1 minus the square root of x. Now, notice here we have an x minus 1, and in the denominator it's a 1 minus x. And what holds true about those two names? They are, Brenda?
Opposite.
They are opposites. So therefore, if we then were to take, well, let's leave that one in there in that denominator. Let's take the opposite of this numerator, of this factor of x minus 1, which would read what? Which would read 1 minus x. So if we take that opposite, let's also take an opposite here, which would read what? The square root of x minus 1. Does everyone agree that the product of those two numbers would be the same as the product of the original two? Okay? Now, looking at that, you see a name for the number 1, which happens to be, Don?
1 minus x over 1 minus
1 minus x over 1 minus x, and so therefore the entire expression reduces to what? The square root of x minus 1, and that then would be the most simple name for this original expression as we have right here. Okay? Well, let me give you your homework assignment, in which